How machine learning works. For most of computing history, computers followed very explicit instructions. A programmer wrote rules. The computer executed those rules. And the result depended entirely on how carefully those instructions were written. But many real-world problems are too complicated to describe with simple rules. Recognizing a face in a photo. Understanding speech. Recommending movies you might enjoy. These tasks involve patterns that are difficult to program step by step. Machine learning approaches the problem differently. Instead of writing every rule, developers train computers to learn patterns from data. Over time, the system improves its predictions based on experience. So today we are going to walk through how machine learning actually works and why it has become such an important part of modern technology. Chapter 1. What machine learning actually is. Machine learning is a method of teaching computers to recognize patterns in data. Instead of following fixed instructions, the system analyzes examples and gradually improves its ability to make predictions. You can think of it as a statistical learning process. The computer examines large sets of data and looks for relationships between inputs and outputs. Once it learns those relationships, it can apply them to new situations. This allows machines to perform tasks that previously required human intuition or experience. Chapter 2. The basic learning process. At a high level, most machine learning systems follow three main steps. First, the system receives data. Second, it analyzes the data to find patterns. Third, it uses those patterns to make predictions about new data. For example, imagine training a model to recognize pictures of cats. The system is shown thousands of images labeled as either cat or not cat. Over time, it begins identifying visual patterns that tend to appear in cat images. When a new image appears, the system compares it to the patterns it has learned and estimates the probability that the image contains a cat. Chapter 3. Training data. Training data is the foundation of most machine learning systems. This data contains examples that help the model learn the relationship between inputs and outcomes. In a speech recognition system, the data might include thousands of recorded sentences paired with written transcripts. In a recommendation system, the data might include information about user preferences and behavior. The more diverse and representative the training data is, the better the system can learn meaningful patterns. Poor data often leads to poor predictions. This is why collecting and preparing data is one of the most important parts of machine learning. Chapter 4. Models and predictions. The system that learns from the data is called a model. A model is essentially a mathematical structure designed to detect patterns. It contains adjustable parameters that change as the model learns from data. During training, the model repeatedly compares its predictions to the correct answers. When it makes mistakes, the system adjusts the parameters slightly. Over time, these adjustments improve the model's accuracy. Eventually, the model becomes good enough to make useful predictions on new data it has never seen before. Chapter 5. Supervised learning. One common type of machine learning is supervised learning. In supervised learning, the training data includes both inputs and correct answers. The system learns by comparing its predictions to those known answers. For example, an email spam filter might be trained using messages labeled as spam or not spam. The system studies patterns in the text of those messages. Later, when a new email arrives, the model predicts whether it is likely to be spam. Because the training data includes labeled examples, the system learns what outcomes are expected. Chapter 6. Unsupervised learning. Another type of machine learning is unsupervised learning. In this case, the training data does not include labeled answers. Instead, the system tries to discover patterns or structure on its own. For example, an unsupervised system might analyze customer purchasing behavior and group similar customers together. These groups can reveal useful patterns that might not be obvious at first glance. Unsupervised learning is often used for tasks such as clustering data, detecting anomalies, or exploring large datasets. Chapter 7: Neural Networks. Many modern machine learning systems use neural networks. Neural networks are mathematical models inspired loosely by how neurons interact in the human brain. They consist of layers of interconnected nodes that process information step by step. Each layer extracts different features from the data. In image recognition, early layers might detect edges or shapes. Later layers combine those features to identify more complex patterns such as objects or faces. Deep neural networks with many layers are often referred to as deep learning systems. Chapter 8: Real-world applications. Machine learning now appears in many everyday technologies. Search engines use it to rank results. Streaming services use it to recommend movies and shows. Voice assistants use it to understand spoken language. Fraud detection systems use it to identify unusual financial transactions. Even navigation apps use machine learning to estimate traffic conditions and recommend routes. In many cases, the technology works quietly behind the scenes, helping systems make smarter decisions. Chapter 9: Limitations and Challenges. Although machine learning is powerful, it also has limitations. Models depend heavily on the quality of their training data. If the data contains errors or biases, the model may reflect those problems. Machine learning systems can also struggle with situations that differ significantly from the data they were trained on. Because of this, human oversight remains important. Machine learning works best when used as a tool that supports human decision-making rather than replacing it entirely. To wrap up, machine learning is a method that allows computers to learn patterns from data rather than relying on fixed programming rules. Models analyze training data, adjust their internal parameters, and gradually improve their ability to make predictions. Supervised learning uses labeled examples, while unsupervised learning searches for patterns without predefined answers. Modern systems often use neural networks that process data through multiple layers of analysis. These techniques power many technologies including recommendation systems, speech recognition, fraud detection, and search engines. Machine learning works by combining data, mathematics, and computing power to identify patterns that would be difficult to program manually. The result is a system that can improve its predictions through experience. While the technology can appear mysterious from the outside, the underlying idea is surprisingly straightforward once you break it down step by step. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. Comment below what other topics you would like us to cover. See you in the next one.